Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graphs. So let us see our today's question. Our today's question says minimum cost to connect all points. Let me read the question. We are given an array points representing the integer coordinates of some points on a 2D plane where points at the index of I equals to xi, yi. Xi denotes the x coordinate, yi denotes the y coordinate. I know you all must be familiar if you have studied the coordinate geometry. The cost of connecting two points xi and yi and xj and yj is the distance between them, and the distance is calculated via this formula. That is the absolute difference between the x coordinates plus the absolute difference between the y coordinates and their sum. Their sum is equal to the distance between these 2 points, and that is the cost of connecting these 2 points. This denotes the absolute value of VA. What we need to do is we need to return the minimum cost to connect all points, and all points are connected if there is exactly one simple path between any 2 points. See, the last line is very important. We need to return the minimum cost to connect all points connected. All points are connected if there is exactly one simple path between any 2 points. It means we need to connect all the points which are mentioned in our points vector, and we need to connect it in such a way that the cost is minimum. So from this line, it is very much clear that we need to apply something as minimum spanning tree. From the last line, we are getting that idea of applying the algorithms which are based on minimum spanning tree. What happens in minimum spanning tree is all the points are connected. There is exactly a single path connecting the points, and the cost of connecting the points is minimum. So first of all, understand this question. In example number 1, we are given with the points 0, 0. So we have labeled it on a 2D plane. 0, 0 denotes the origin. 2, 2 denotes your first point. 3, 10 denotes the next point. 5, 2 next, and 7, 0 next. These all are the points. Now we need to connect all of these points such that the cost of connecting these points is minimum and there is exactly one path. So what we can do? We will see. If we start from 0, 0, we are starting here 0, 0. If we connect it to 2, 2, the cost is 4. Then from 2, 2, we connect to 3, 10, and so on. So this will be our minimum spanning tree for this particular question. How we are able to calculate the cost? With the help of this formula, that is the absolute difference between the coordinates. If I want to calculate the cost between 0, 0 and 2, 2, what is the absolute difference between their x coordinates? 2 minus 0 is 2. And absolute difference between the y coordinates, 2 minus 0 again 2. So 2 plus 2 is 4, which is the cost connecting 0, 0 and 2, 2. If I want the cost for 0, 0, 3, 10, I can calculate it in the similar fashion. So I hope how to calculate the cost is very much clear to you all. We have drawn the minimum spanning tree. Now the main thing is this only. If you have studied the minimum spanning tree, the main thing is to detect how to form the graph with the help of these points. If you are able to do so, then after that you can apply any of the algorithm, either Prim's algorithm or the Kruskal's algorithm. Both will work fine. So let me explain you the question with the help of code now. What we did. We have made one separate function for calculating the distance in which we are passing two vectors. What is the, how we are calculating the cost? The absolute difference between the x coordinates, this is this one, and the absolute difference between the y coordinates, and their sum is equals to the cost between the 2 points. So this function distance will return us the cost between the 2 points if we will pass two vectors in this. So we have made one separate function for this, calculating the distance. After that, we have defined one adjacency list. Why points dot size? Because the total number of points is equal to the size of the points vector. So that is why in adjacency list, we have defined it with a size of points dot size vector. For n I equals to 0, I less than points dot size, I plus plus, we are iterating through this vector. For n j equals to I plus 1, j less than points dot size, j plus plus. Int w. Int w denotes the cost. For this, we are calling the function distance and passing two vectors, that is points at the index of I and points at the index of j. After that, ATJ at the index of I dot push back W comma J. I hope you all know this particular thing if you have studied the weighted graphs. This line denotes that there is an edge connecting I to J and the cost of connecting I to J is W. In the similar way, there is a edge connecting J to I and the cost of connecting J to I is again W. So in this way, in adjacency list, we are defining these points. After that, we have made one map with keys as int and boolean visited, so that we can make the count whether that particular point or that particular node is visited or not. Initially, we have given all the nodes as visited false because we have not visited any of the node yet. Int minimum path equals to 0. This variable will help us to store the minimum cost to reach all the points through a single path. And this value only we need to return in our question. Initially, we have defined it with the value 0. After that, priority queue means min heap, we have defined it here. What happens in min heap is the minimum element is at the top and we can access it at first. So after that, we have iterated through our adjacency list. We have pushed this in our priority queue, that is PQ dot push X. After that, visited at the index of 0 equals to true because we are starting from 0th index, while not equal to PQ dot empty. Int U is equals to PQ dot top dot second. And int W equals to PQ dot top dot first. Then we are popped out a single element from over here. What does it denotes? PQ dot top dot second. PQ dot push X. What is our X denoting? In the similar way, the first thing is our weight and second thing is our node connecting towards it. So U denotes the node connecting and W denotes the weight. PQ dot pop. If we have not visited that particular node yet, then we will visit it. When we will visit it, we will mark visited at the index of U equals to true. And we will add that particular distance to our final answer, that is min path equals to min path plus W, that is min path plus equals to W, which we have defined in line number 30. After that, we will iterate all the nodes connecting to that particular node which we are accessing right now, that is int U equals to PQ dot top dot second. If it is unvisited, we will pass it into our priority queue, otherwise we will not pass. And at the end, we will return the min path. And this thing we need to return in our question. That is the minimum cost of connecting all the points. What we did, we have done nothing. We have only applied the Prim's algorithm in this particular question. The main funda is this one, how we are making the graph and the approach. If it is clear to you, after seeing the last line of the question, we need to visit all the points and by exactly one path. Minimum spanning tree should click to your mind then and there. If it is clear, then you can apply any of the algorithm, either Prim's or Kruskal, both are going to work. I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.